All right, good morning and happy Sunday. So today I'm planning on doing the LeetCode contest from yesterday. Let me share my screen real quick and then we'll start jamming on this one. Okay, so LeetCode contest 298. That'll be the game plan. Let's do it. All right, open these guys up. The clock is ticking and we are keeping score. 10 to shine. Okay. I want to uppercase and a lowercase of each. Uppers. Oops, lowercase of each candidate. Then max candidate. And that's the game plan. Let's do this in C++, is fine. Okay, 6:17 a.m. That's for implementation in C++. Let's see. Set is a word. Set of characters. Okay, so if it's upper and lowercase characters are different character sets, right? So the difference between uppercase and lowercase, hold on, let's do this actually. The ordinal value for lowercase is 97 to 122 inclusive. Uppercase is from 90 or 60 to 90 inclusive, right? Or 65 to 90 inclusive, I think, right? Is that right? Diff is 32. Okay, yeah, let's do this set scene. Use the constructor for it. Messed up again. End. Okay, so there's none that's uppercase and lowercase. Chart best equals just empty string, right? Oops, hold on. So return a character. No, it returns a string. String representation of the best character. It's fine. Let's just do this. It's a character which will cast into a string. String of one best. Just do this. It's fine. Let me check this real quick. String C turn C++. I get this backwards sometimes. Right. One of that character. That's all right. Okay. Looks good. Okay, so for character is A. Character is less than or equal to Z. If scene.find character and scene.find character minus 32, then best, let's see. Okay, run this guy. Oh, that's car best on empty character constant. Oh, do you want to, is this no value for best then? 0 is less than all those. I think the SQL value for 0 is like 48. Okay, so best exceeds 0. Lies. Empty string. Scene.find C. Oops. It's not equal scene.end. That does not equal scene.end as well. E, we want it to be uppercase. Return in uppercase. Okay, fine. Let's just have it as uppercase here. And add 32 for the lowercase equivalent. Looks good. ER empty string. Wait, there's a space there. What? Why is there a space in front of this thing now? Oh, I think, yeah, it's using the initializer list. Oops, I don't want that. Okay, that looks right. Cool. Okay, so 6:23, about 5 minutes. Okay, let's post this and then move on. All right. C++ is the first one. Consider all candidate characters C from A.Z inclusive. Or the for which there exists both the uppercase and lowercase character values. Wow, consider all candidates, right? That sounds good. And return the graphical maximum. If it exists. Sounds good. All right, whatever. You want more details, go read the problem statement yourself. Right, it's good enough. Okay. Python 3, Rust. Okay, let's jam. C++ is cool. All right, so scene equals a set of characters for each character in the string for character in range. Ordinal value of the uppercase letter A to the ordinal value of the uppercase letter Z inclusive. If scene, characters in scene, and let's just do the ordinal values. This is fine, right? Wait, hold on. Char. This is X. So char X in scene and char. Oops, char X plus 32 for the lowercase equivalent. Scene, and that's a candidate for best, which is the lexicographical maximum. Return best if best does not equal our signal value. Otherwise, return an empty string. Best equals here, let's Looks good. Good enough. Doesn't have to be perfect, right? We'll save Python or Rust for last, since that one I'll have the greatest difficulty with. Let's do this, or equals function which will return c.char code 0. Let's see if s not have scene as a set, scene equals new set, scene that it's fine. Scene dot add character for character of how do I want to do this? Let me do this like A, B, C, D, F, G, H, I, J, K, L, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. It's fine, whatever. Return, oops. Return. Best does not equal the sentinel value. Return best. Otherwise, empty string. If scene dot has that character and scene dot has character dot from char code ordinal value of the character plus 32 or its lowercase equivalent, something like that, and the best equals C. From char code. Oh, I think it's string actually. String from char code. Ordinal value looks good. I watched Top Gun Maverick yesterday, so I should call that Splash 3. Oh, actually, yeah, that's cool. Whatever. Let's hold on one sec. Okay, whatever. Yeah, I wanted to actually change my background, so looks like I'm having more fun. Having fun is important. There we go. Calm me down so I get all flustered too. Okay. Let's get to it. I want to make sure there's time for the last question. Hope I can get there. Kotlin. Let's do this. Seen as a mutable set of characters. Or actually, let's do this. S.2 set. Doesn't need to be a mutable set. Or character in maybe C, D, E, F, G, H, I, J, K, L, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So scene that contains C and scene that contains. Actually, let's do scene dot s.2 set dot map it dot to and just use the ASCII ordinal value. Scene dot contains that dot to int plus 32. Actually, I have to change it back there, right? So let's just keep it like this. Character dot to int and the character from that value. I forget how to do that in Kotlin. Hold on, Kotlin character from ASCII ordinal value. Is this string dot to and ASCII code to character .tochar. ASCII value .tochar. How interesting. Okay. Okay, if it equals this guy. All right, it has that guy and it has this guy .tochar. .tochar, then best equals that character, return if best does not equal the signal value, return best, otherwise as a string, right? Choose string. Does this work? I don't know. Let's see. Expecting an element range as an iterator. Oh, Kotlin double quotes for strings. Expecting an element, best equals C. They're expecting an expression, result reference best. Best is that character. Really? Char array. Iterate through that, expecting an element. Really? Elements. What is going on here? The character. Okay, yeah, that's fine. Scene that contains candidate. Println. What is going on? Oh, we have that. Okay. Missing a right print. Okay. Well, thanks a lot, Kotlin. That didn't really help out too much. It's extremely difficult to find that out. All right. The compiler is telling me that I was missing a right semicolon. Or not a right print, right? Like closing print. Okay, that looks good. 6:34, about 5 minutes from Kotlin. Okay, do rest and move on. Doesn't have to be perfect, it's good enough. Okay, so let me best equals signal value. Let's see, best does not equal the signal value. Best, otherwise, return an empty string. Hash set or CNS. We'd seen this new hash set. Scene.insert. Or that guy. Or C in B, C, D, F, G, H, I, J, K, L, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Chars, those if scene contains character and C that contains the lowercase value of that character, plus character two lowercase. Let's see, two lowercase, string not two lowercase. Two lowercase. I don't know if that works in a character or not. Let's see. Okay, now it's time to fix the collections. See, collections hash set contains borrow is not limited for char. Equals not implemented to string. List of to string. Two lowercase to string from this guy, two lowercase, and then as say rest string to character. Man, the charge to collect. There's got to be a better way of doing this. I totally suck at Rust though. I'll do my best, whatever. String from this guy, two lowercase. This is two lowercase, two char ready to collect. Okay. Two lowercase dot chars dot collect into a vector of chars from which we can take the first one. So ugly. Holy cow. Okay. Sharing parameters with that surrounding angle brackets. Oh. Oops. Okay. Surrounding angle brackets around that. I need some more coffee. That thing. Oops. I might just come back to this as Rust takes me a while. It's just two string, interesting. That is a string though, isn't it? Oh. No, it's not a string, it's something else. Stir reference. Okay. Clone that guy, take reference to this. Let's see. Whoa, it doesn't live long enough. See that? Oh, okay. All right. We'll copy that thing. Oh, it looks good. Okay. Okay, cool. All right. And significant room for improvement with the rest. Good enough. There's a few solutions. Let's move on. Okay, how much time we got left? We have 1 hour, 5 minutes remaining in the contest for Q2, which we'll do in maybe like Python 3. Okay, 6:41 a.m. 5 minutes. 3. Okay, and we have 1 hour, 5 minutes remaining in the contest. Let's go. The units digit of each character are integers. Okay. Units of digit 2. Each integer has units of digit 9. The minimum possible size of such a set. The sum of an empty set is considered 0. Okay, so if num is 0, then it's 0. Otherwise, what do we take? Subtract 9 from it. See if there's a 9 in that. Otherwise, subtract 9 from it. Okay, so game plan. Do the implementation next. So the game plan will be to continually subtract k from x, so it be x, and count the iterations until x is less than or equal to 0. If x is 0, then we return the count, otherwise return -1. 6:43. 2 minutes for the game plan. 6:43, we'll start the implementation. All right, how many minutes for implementation? On 3. While x exceeds 0, inclusive, count to 0, return not x, count if not x, otherwise -1. K x minus equals k, count plus equals 1. That is not right. Oh, okay, so actually it needs to be until, okay, so this is the wrong game plan, actually. Hold on. Oops. The game plan is off. Okay, we only subtract k from x until x contains, right? X contains the value 9 within it, right? Minimum possible size of such a set. Multiple instances of the same integer. Some integers unit. The units digit is the number, is the rightmost digit of the number. So once the rightmost digit of the number is k, until the rightmost digit of x is k. Okay, so this is wrong. 6:45 for incorrect implementation. Initially, I read the problem statement incorrectly. Oops. It doesn't matter though, because mistakes happen and that's perfectly fine. While x exceeds 0, and the rightmost digit of x modulus 10 does not equal k. Minus equals k, count equals +1. Okay, that looks good. Uh-oh, that is not right. Let's print x as it's transformed here, because it should be 49, right? 49. Oh, okay. Hold on. If not, x modulus 10 equal k. It's not equal k. Or equals k. If it does equal k. Okay, so count +1 then. Count +1, and then make sure this works okay for the edge cases. 2, -1, 0. 2, -1, -1 is not right. Not X is a corner case. Really, X is let's just handle as a corner case. If not X, return 0. 2 negative 1 0 is legit. Okay. Let's do this. Sure, it's taking a while. Uh-oh. It's 2, I expect to be negative 1. Oh. 6 and 2. Okay. Incorrect solution. 645 to 648. 648. 3 minutes. Solution. X equals 2. K equals 6. Output is 2. Expected is negative 1. X equals 2. X needs to be greater than 0. Still right. Am I missing if expecting to block after class? Oh. Two negative 1 0, and this one should be negative 1 as well. Looks good. Sure, it's taking a while. Oh crap. Okay. TLE. Uh-oh. Man, I'm having a hard time with this one. Okay. 648 to 650. 2 minutes for another incorrect solution. Might as well keep failing forward. It's cool. That's all right. Mistakes happen. We can learn from them and move forward, right? Okay, so when X equals 4, K equals 0, then I get TLE. Can't subtract 0 from that guy. Okay, so if not K, return 0 if X modulus 10, right? Otherwise negative 1. So the corner case I didn't consider is 4 0. 4 0. And then 10 0 should be 0. Okay, that looks good. Oh, no way. I put 0, but I expect 1. Ah, it's a set of 10 itself. If not K. Should be 1. Okay. AC at 6:52 a.m. I took a total of 6:41 to 6:52. 6:41 to 6:52 a.m. About 11 minutes. To fail forward and arrive at AC eventually. Yeah, better than giving up. Yeah, could be worse, I guess. I don't know if I want to clean this up or not. This is just a really ugly solution. Let's just look at this real quick and see if I can clean it up a little bit. We could do this, right? Wow, that's okay, and looks good. A little bit cleaner, not X. Turn 0 if not X, else. Count +1. Let's do this. Let's count 2. Okay, that's not right. X is 0. X is 0 here, and it should return 0. Zero if not X. So it's not quite right. Let's do this. X return 0. Otherwise, do that. That's good enough. Right, that's probably cool. We have to have K. Then reduce X. Good enough. Let's move on. Let's do this in the other languages real quick. A few solutions. Oops. A few solutions. 3. Kotlin. JavaScript. Rust. C++. Okay. $6.55. If not X, return 0 is our corner case. Then while K and X return 0 and X just 10 is K. Count as 0, or actually count as 1. Return X exceeds 0 and X modulus 10 does equal K. Then we'll return the count, otherwise -1 is not possible. And then all this occurs on X minus equals K. I've got the count. Oops, 6. Hold on. Looks good. Okay, 6:55, 6:56. Good. 6:56. 1 minute. All right, JavaScript. Should take less than a minute as well. Count is initialized to 1. X return 0. X while k and x is greater than 0 inclusive, and x modulus 10 is not equal to k. X minus equals k. Count. X is greater than equal to 0, and x modulus 10 does equal k. Then we'll return the count, otherwise negative 1 is not possible. Looks good. It's cool. Okay. Splash 3. All right, here we go. 6:58 a.m. Let's go. If x is equal to 0 is our corner case, return 0. Otherwise, while k is greater than 0, so we have to reduce it, and x is less than or equal to 0 inclusive, and x modulus 10 does not equal k. X minus equals k. Count. Just 1 initially. If x exceeds or 0 inclusive and x modulus 10 is equal to k, and return the count, otherwise negative 1 is not possible. Value cannot be reassigned. This goes. Looks good. Splash 4. Make x mutable so I can change it. Let me count equals 1. Return the count if x is greater than equal to 0 and x modulus 10 is equal to k. It's the count, otherwise negative 1 is not possible. If x is equal to 0, return 0 as our corner case. Then while k is greater than 0 and 0 is less than x, and x modulus 10 is not equal to k, then x minus equals k, count plus equals 1. That's good. Splash 5. All right, let's get on with it. Have a little description and get on to Q3. Attempt to reduce x by iteratively subtracting x by k until x, let's see, while x is non-negative and the rightmost digit of x does not equal k. Yeah, that works, right? Good enough. Nothing too fancy or perfect. And we have 45 minutes remaining in the contest. plenty of time for Q3. Maybe I'll do it first in C++. Q3 start. 45 minutes remaining in the contest. Okay. We'll grab some more coffee real quick.
Hey, good morning, Secretary.
Yeah, there about 45 minutes yesterday. About how good what you said. Okay. All right. So return the length of the longest subsequence of S that makes up a binary number. Let's drink it to K. All right, empty strings considered 0. Subsequences, okay, yeah. Longest subsequence of S that makes up the binary number less than or equal to 5 is that. This number is equal to 2 in decimal. Note that this is 4 in decimal. This is 5 in decimal. Okay. Do a bunch of zeros, I would suppose. Subsequence. K is billion. How many zeros can you stick in front of ones? So 4 a.m. for our game plan. Okay. So the question comes down to this, right? Right. Maximize the number of zeros we can place in the front of ones. Right. The length of the string is 1,000. Empty string can be considered equal to 0. So how do I want to do this? Make the longest substring of S. Left to right or right to left. Maybe right to left. Take as many zeros as we can before ones. And the zeros are safe. Yes, yeah, zeros are safe. Leading zeros are safe. Trailing zeros are sketchy. May maybe safe. unsafe. All right, so that depends on the ones in front of it. So I don't want to formulate an answer for this. Longest binary subsequence where the cardinality input string is up to 1,000. Quadratic solution may be accepted then in that case, right? So we have the best ending at each index j for I to j, not inclusive, or I to j inclusive, right? Best ending at. I think that works. Okay. Since the cardinality of the input string S is at most 1,000, a quadratic runtime solution may be I best ending here at each j index and continually attempt to build upon that previous solutions to find the best as our objective. All right, okay, so that's the game plan, I think, and that seems to make sense, right? So for each j ending index from j equals 0 to n minus 1 inclusive, or n is equal to the cardinality input string s, basically go j, I, j, build the i's towards the j, or return the best j that we can find, right? So best equals 0. That's the game plan, at least. Let's see what happens. 7:09. 5 minutes for the game plan. Start implementing it. It's 7:09 a.m. 5 more minutes. Oops, minutes for implementation. C++. Trying the best in the end. And it goes size. J is 0, j is less than n, I up to j. It's the piston in here. Piston in there previously. Managers just store those. And best in here, any index is 0 by default. So the previous one plus 1 if it's okay. It's a safe move to add that shade character. So, all right, does this work? Or just like, hold on. Sure. Cast that into, cast it to an integer. It's a little tricky. Let's go through an example. I'm not sure if this will work or not. 6 equals 7. So this is in, we have I and J. If S sub 0 is less than or equal to K, dp sub 0 equals 1, ending there. So K for the first example is 5. K is 5, okay. S sub 0 equals 1, which is less than 5. dp sub 0 equals 1. Now building upon that, J is this guy. Ending here, pin to there. Best one in here is size 1. The value be though, for I and J, the substring value, subsequence value. Subsequence value ending at I, appending J onto it. So do I have to keep track of the smallest subsequence value? A question, in addition to tracking the objective function, dp sub j has the best ending here at each jth index. We would also need to track the minimum subsequence value ending at jth index, so we can determine if we can append onto it. Right, say for the best solution ending at a previous ith index, can we append the current jth index onto it such that the value of the subsequence in decimal is less than or equal to the threshold, saying t. I think so. I think that makes sense, right? So dp sub I would be the best ending here at each jth index, which would be a previous r that we can pin j onto if and only if the value of the subsequence converted from binary to decimal is less than that threshold t. It's always multiplied by 2, right? 2 use cases to consider. for appending each jth index candidate to previous ith solutions. Case one, S of j equal to, I guess in either case, we multiply the previous ith solutions value by 2. I bit or shift left by 1. If it's 0, then no op. Case 2 is when S of j is equal to 1, and we do +1 onto that shift. All right, +0 onto the shift. Okay, so we'll just keep track of the ongoing value. TP is the best, and then what do I want to call the other thing? I don't know, we're all this thing value. Value seems okay, right? So K can be a billion. So it seems like I need a sliding window size 9 at most, maybe. Maybe a sliding window size 9. It could have a whole bunch of zeros though too ahead of it, so that's not quite right. Of longs, VL value, so and value sub 0 is equal to 1 as well. Candidate value is the previous value, ending at I. Shift to the left by 1 to include take this 1 as a character, and S of j is equal to 1. True or false. That's the candidate. If the candidate is less than or equal to our threshold, then it's cool. dp sub j is the maximum of itself, and 1 plus the previous solution ending at I, and then the value ending at j is equal to the minimum of the value in the j and the candidate value sub j. This seems to imply if it's the minimum, we'd have to initialize it to infinity or some sentinel value. 29.7. Okay, it's the minimum of the values j and candidate built upon I. Best is then equal to the maximum dp sub I for all ig inclusive, right? Max element dp in dp dot end, something like that. Okay, 709 to 722, and that is about 13 minutes. Okay, let's see what happens. 5 is correct. The one should be 6. 0 is not correct. So it's not quite right, not quite as naive as this. Let's see, this is the wrong answer. Correct solution, right? Which results in the wrong answer. Okay, so this guy is that. Okay, equals 8. K or the threshold equals the threshold is 1. Okay, so my answer is 5. Or no, my answer is 0. Should be 6. Expected value is 6. Okay. J initially is set, TP sub 0 is set to, hold on. Let's do this. TP sub 0 equals value sub 0, which is equal to integer value of s sub j is equal to 1. So it's either 0 or 1. It's not quite right. Hold on. TP sub 0 equals value sub 0 is less than or equal to t. So then you go to that initial threshold. It's 1, and there is 0. And there's 0 is less than t to initialize it. Okay, let's get rid of this guy and then threshold. Oops, sub 0. 6 is correct. Okay. 5 and 6 looks good. Let's see what happens. Oh, wrong answer. Okay, it's pretty big. Output's 33, but I expect 31. So my solution is too good. This guy, threshold is that guy. Output's 33, but I expect 31. So I'm counting too many. You allow for allow to be too big. shifted left by 1. It's too big. Is it wrapping around? I don't know. Let's try this. I can try this in Python 3 as well. That might work out better. Let's give this a shot though. Let's put 31, got 33. Nope. Long doesn't help. Change long to long. And that doesn't help. So, Mr. Right. Oh, what could be wrong here? I guess what's going on here? I know S is 1,000, right? So that's pretty big if you try to change that to a integer. Oh wait, I only need to shift. Wait, yeah. It has something to do with the shift and then dropping the ones eventually. I like to drop leftmost ones. Yeah, see how much time we have left. Okay, 18 minutes. 18 minutes remaining in the contest. So how much did I have for this one? I had 45 minutes, took about 30 minutes or so. Q3 took about 30 minutes. And now either debug Q3 or start Q4 to do next. I don't know how to solve this one offhand. I might have to take a break and come back to it, but I think in sliding window has something to do with it, right? So there's a 1 in that window. I guess we could drop that window. Subsequence. Yeah, it's tricky. A greedy solution, maybe. You take all the zeros and start there. And then start inserting ones. Like, that'd be just a radical change of pace. What if we start with the subsequence of all zeros, then greedily attempt to cherry pick added to their respective rightmost positions, such that the result value is less than equal to question. Maybe, I mean, that's fundamentally different than what I was trying here instead of programming over them best unit J. It sounds complicated though. Let's try walking through this real quick. So S equals this guy. And best solution with all zeros would be zeros are there's 4. 1, 2, 3, 4. Okay, so that's I think 4 for all zeros. The show value is at least 1, so that's always a safe move. Since T is greater than 1, this is always a safe start. Try to stick it there. So we fill in this rightmost one. Start filling in rightmost ones. One, two, three, 1, 0. When we add our rightmost one, then we accumulate an ongoing total of powers of 2, starting with total 0, t plus equals 2 in this case. Index of the rightmost one. So 1. It's 2 to the power, right? 2 to the power of the index of the rightmost one. Each rightmost candidate we append onto the zeros. I think that might work actually. I'm going to keep it super simple, right? KISS, keep it super simple. Let's see if this works out. And then I might have enough time to do this. Actually, that'd be cool. And then I'll have some keep further on fresh. After I take a break. I said n equals 8. For example, 2k equals 1. I'm going to call it t is our threshold of 1. So initially, we have how many zeros? 1, 2, 3, 4, 5. 5 zeros. And plus 1 on the right. I think that works out. Okay, so see how much time we have left. We have 11, about 12 minutes left. Let's do this. Let's try implementing this. Right. To implement this in 12 minutes. Let's give it a shot. Okay, so this stuff, ongoing total, size, okay. 0. Let's do this. Best equals count if step in, character is equal to 0. Those are all our zeros, and go from right to left. I equals a minus 1. 0 is I, or I is a minus 1. I. Okay. Best to your end. t plus equals, let's see, if I is equal to 0, and we increment best without modifying the total, otherwise if I equals 1, continue here. If I is equal to 1, and we increment onto the total plus equals 1, shifted left by n minus I minus 1, and minus 1 minus I, right? The last one minus the I. Wait. To the right, especially. Maybe it makes sense to reverse the string. It might make it easier. Let's do this. Reversing the string will make the calculation easier, right? Or how to reverse this type of demand, this demand. 0 just minus I. If this of I is equal to the character 0, then it's just a no-op, it's cool, right? So we already counted that 0. Otherwise, we'll add the 1 onto that position. T plus equals 1 shifted left by I. Excuse me. If T is less than or equal to T, then we'll increment best. Otherwise, we'll break out of the loop. Something like that, right? Let's do this. 5 and 6 is cool. 31, all right. Oh, shift exponent 37 is too large for int. Yeah, that's right. Long. Come on. Using long. LT. Oh, what? Hold on. Fast. What? Shift left by I. No, 8. Oh, runtime error. Shift exponent 500. Oh man. Okay, that's what I was thinking. It's easier in Python. I got 5 minutes. Sorry, let's do this in Python. Basically the same thing, right? 5 minutes remaining. Let's do this in Python 3 since it handles large numbers better than C++. Okay, so best equals length of character in S if character equals 0. Turn the best at the end. Is our threshold t equals 0 for I, C, and enumerate S reversed if character equals 0, continue. Otherwise, total plus equals 1, shift left by I. If total is less than or equal to our threshold, best is incremented by 1, otherwise we'll execute. Okay, that looks good. Maybe it's okay. All right. Yeah. Nice. Okay, 4 minutes left. Okay. Yeah, that one took a while. That's awesome. I stuck with it. Totally kept believing in myself, stayed positive, and I finally got it. So that's cool. I wasn't sure if I was gonna get that one, so that's awesome. Now I'm wondering, how can I do this in the C++? Oh, if I is ever bigger than a billion, right? I think I can fix this up. If I is ever bigger than a billion. If I exceeds 9 and it's bigger than a billion, right? Would that work? I wonder. Let's see. Maybe. Nope. Oh, the subsequence, right? I character. No. How many zeros are to the right? Okay. Fix this up to work with large numbers. Basically, I need to exclude candidates which cannot, right? It simply cannot be candidates. Rather than switching languages to Python 3, which handles large integer values. Right, so candidate values for one shifted left by I if the total is too big. How do you shift it? Oh, I is 32 bits, right? If it exceeds 31, yeah. Just in time. All right. Don't celebrate too much. Let's get to it. All right, let's clean this up and do the other languages. We still, so I got, that's Q1, Q2, and Q3. Q4 I didn't get. A few solutions. JavaScript, Python 3. Don't forget Rust. Okay, we'll jam on these real quick and then call it a day. I'll upsell Q4. We're kind of out of time to get to it, but this is pretty much the end of the contest. Got 3 out of 4. which I'm totally stoked. This is cool. Having the psychological flexibility of moving from DP solution to a gritty solution. Yeah, that's awesome. Sometimes I get stuck up, hung up on stuff, get negative. It's awesome to stay positive, keep focusing forward, do my best. That's all I can do. A decent solution. Use this once, might as well get rid of that. And then how I want to state this. If my threshold T is exceeded, then we can break. Otherwise, we can increment best. Increment best by 1. It doesn't have to be perfect. I mean, this is a decent solution. Yeah, good enough. It doesn't have to be perfect. Okay, so greedily consume the subsequence of all zeros initially. Then attempt to place ones onto the best solution. From right to left, by least significant bits first. And while the ongoing total T is less than or equal to the input threshold T. Just cherry pick. That makes sense. Okay, that's cool. Okay, so that's C++ and Python 3. It's cool. Let's do this. So T exceeds our threshold, break, otherwise we're increment best at 1. It's cool. Okay, let's do this in Kotlin, JavaScript, and Rust, and we'll call it a day, right? /2, /1, /2. Let's do JavaScript. 1 AM. That's for implementation. JavaScript. All right, finish strong here. Let best equals the length split filter character on 0. Length of that. Return the best in the end. Okay, and then for step reverse 0, I is less than the length of s. So I is equal to 0, continue. Otherwise, let's say check our total. If I exceeds 31, break, this total is 1, shifted left by I. If our total exceeds our threshold, we'll break, otherwise make it best by 1. Reverse s dot split dot reverse dot join t is not, oops, t is our threshold. Go 501 is not right. 107 is not right. It's off by 1. T exceeds our threshold, non-inclusive. Stop length. I exceeds 31. Best. Sure. First one's fine, but the second one's not okay. It's going to be 6. 1, 2, 3, 4, 5, and then they should add that 6th one. Oh, wait, hold on. Total exceeds our threshold. Non-inclusive. Break. I exceeds 31. That doesn't happen. One shifted left by I. Should equal to 1. What the heck? I don't know what's going on here. Why is this guy? T is that guy. Oh, S is equal to that. Okay, that looks good. Oops, hold on. Okay, it's probably all right. Let's do this. Oh, it's not right. 109, but expect 108. Uh-oh. Shit, my eye. Hmm. $300 million. What am I missing here? It's one too many. One too many. You are now. Looks exactly like this, doesn't it? Hmm. That's strange. Stack. Yeah, I'm obviously running on empty, so I'm gonna upsalt these ones later. Catch you next time.